This is chapter 26, example 5. So this turns out to be quite a busy example. The way we're going to handle this is to take it step by step. Now, these are a lot of circuits you've seen before, but now they're all working together. First thing we're going to do here is put the black box diagram, high level. And so we'll read this to make sure we get it right. It has A and B input. They're 8-bit radix complement numbers. And what else do we have out here? It has a couple buttons on this, so it looks like we ran out of space. We'll call this a button that starts the circuit and a button that chooses whether this 40 or 50. So this 40 or 50 is the maximum count, after which it resets. So we'll call it BTN max, and we'll call it BTN STRT. That's my two button inputs here. And so we can erase that, make it look a little bit better. And it has an output count here. The count out is 40 or 50 maximum. So that easily fits into 6 bits, and there's my count output. This is quite a busy circuit, a lot of modules in it, so that I've seen them all before. So let's like break these down. Okay, so it's adding A plus B, and it's outputting whether the result is both negative and valid. Put that in there. I'm not sure where we're going to do this. Okay, this circuit you've seen before, but what we're doing here is checking to see if it's valid. Okay, so this is our standard valid check, where we're looking at the sign bits of those 3 values, which is the 2 input operands, the ripple carry adder, and the sign of the sum. So if that's valid, this is our magic valid box that we won't bother defining here. If this is valid and the number is negative, so essentially what this means is this output here, which is the most significant bit, or the sign bit, is a 1. So let's like fill these in. These are... Okay, so we marked those so we don't have to mark them any better. And it's okay. The next thing that we notice in the circuit is it's an event counter. The event that it's counting happens to be this event right here. I don't know what you want to call it. I don't think we need to call it anything, but what we're gonna do is connect that to a counter. Synchronous, there's the clock. I don't think I need an RCO on this one. If it turns out I need an RCO, I can come back and add it later. Here's our addition module. Here's our event counter. And what we need to do is take a look at that count. Now, if that counts 40 or 50, I want to reset it, and that's going to be based on a button press. So to do that, you could do it with logic, but the easiest way, particularly in this problem where I'm running out of space, I'm going to put 2 comparators there. And the thing it's comparing is the count. We'll drag that count down. And so one of these counts is going to be 40, which is hex 28, 0x28, and we would call this 8-bit. We don't need to do that. Call it 0x28. It's 6 bits. Because this output is also 6 bits. And this is 6 bits and 6 bits. And the other count here is 50. 50 is 3 times 16 plus 2, so 0x32. That's 6 bits. And we both have EQs coming out of these things. This is what we're interested in. Okay, so now what's going to happen here is this. When it's equal to 40 or 50, we want to reset this counter. Now the issue is whether it's 40 or 50 is based on a button press. $50 equals press, so we'll call this 1 and 0, and we'll make an output here. And I don't think we can connect this to anything directly. It's going to be a control signal. And at this point, now the state machine is is going to be clocked, of course, but I'm going to look for all my control signals and my output signals. What I need to do occasionally is clear this counter. And so there's my clear, and that's a control signal from the state machine. No other way to do it. I'll know when to do this when this max value turns on. Nope, I forgot to do something. This is BTN STRT. This tells me to start this circuit, and I think I'm ready to crank out a state machine on this one. Now I really don't know if this is right, but I'm going to start with a state diagram and see if I can make it work. It's waiting for a button press, and so here my wait state, and it's waiting for this BTN start. And when I get that start, I'm going to go over to this circuit, and I don't even know what to name it yet. So what I need to do in both of these states is handle this clear output. And so essentially for this guy, when I'm in this state, I'm going to hold this thing. So with no button, I'm not going to clear it. If I get a button press, I am going to clear the circuit and start again. That looks good. At that point, I've handled the one output. It's a mealy output. It's the best way to do it, easiest way to do it. So in this state, I'll just call it the count state. Okay, so in this state, I remain counting for so long as I don't get a max signal. So once I do get a max signal, I stop counting. Okay, so and that's the important thing here. The other thing here, I have to handle in this state, I have to handle that output. Certainly, if I'm counting, I want to make sure that clear is turned off. In this state, clear is handled as a mealy output. In this count state, clear is treated like a more output, which is completely valid. And I guess I could have listed it up here and down here, but I don't think that's a good idea. It gets confusing. Typically, if the output doesn't change for a given state, it's something you want to put inside the state. It gets confusing if you put it outside the state. So I'm going to look at this one more time and make sure I've covered everything here. I don't see anything wrong with it. I do have to say how this is controlled. So here's a control input. It's controlled by an external signal. Here's a state machine, circuit control, and here's internal signal as well. And so that's going to be three things. This is internal. Okay, looking good. I know I need to do one more thing here, and I'm going to call this clear is asynchronous. These are notes. I've done everything I can think of on this problem. I've got everything listed. I call this done.